Here in this video, we will be building a fraud detection model that is for mobile money transaction domain. This would have shared functionality. This mobile money transaction will have similarity with the credit card transactions, okay, right? So which will be helpful for you to understand how to build a fraud detection model on any sort of payment cards. So this I am going to make basis on the data which is available on Kaggle, this synthetic financial data for fraud detection. So this is a synthetic data which has been created by this person, okay, and this data has been created using Pi Simulator, right? Pi Simulator is another tool using which this data has been created, right? So we will be using this particular data. Different people have created their own solution. I will be explaining you my solutions, and not only one, more than one, okay? So I will be explaining you my solution, which will be absolutely from a beginner perspective. So please be with me. The video could be a little longer, but definitely this is going to help you. So to start with any model, what is first important? The approach. So there are two approach which we can take. First one is we would have three segment in developing any model, right? First one is initial stage, then middle stage, and then last stage. What happens in initial stage is we gather the data. Then in the middle stage, what we do is we do exploratory data analysis, feature engineering, feature selection, etc. Okay, and then on the last stage we develop the model and evaluate that. So this is the step by step method of developing any model, right? You can say forward method. Now the other one is the other approach which we can take is you have initial stage, and then whatever data you have available, just by making some little bit of mandatory changes, you directly build a model and evaluate that. And whatever evaluation you came up with, basis on that, you again go back to the middle stage and you do the some sort of exploratory data analysis, feature selection, feature engineering, etc. Means you make the modification in the data. Then again you come back over here and run that model, and you keep on doing this till the time you get 100%, I mean the satisfactory result, right? So in this video we will be trying a combination of both of these approaches, the first one and this the second one, as we progress. Okay, now before we start with, I will be sharing the link of this particular Kaggle segment right in the description section. Please check that out. Okay, in this, why I want you to check out, because this has the description of each of the variables. There are 11 column in the data which we are going to use. You can download it from here, right? And that would have 11 column and somewhere 6.3 million of records. Okay, so this is the data which we are going to use, and this is the description of each of the columns, right? So don't worry about it. I'm going to take it into the Jupyter notebook, and as I keep on explaining the process, I will be explaining the variables as well. Okay, so let me take you to the Jupyter notebook. Here we are in Jupyter notebook. First we will, I'm going to explain you from the perspective of an absolute beginner, right? And whatever comes in between, we will understand that. So to start with, as a rule of thumb, we generally import all these libraries, right? Import Pandas as PD, import NumPy as MP. This is because these are very common libraries which are most frequently used, right? Then we would require to do some sort of visualization, so we will be importing Seaborn library as SNS, and then because we are developing the model, so of course we need to use the sklearn library. Okay, let's import matplotlib also. From import matplotlib.pyplot as plt, and then from sklearn dot let's say model selection, because we will have to make the model selection. Import train test split. If you want to understand train test split, what train test split is, check out my previous videos. In those videos I have explained this. Okay, from sklearn I will again import sklearn dot linear models, let's say linear model, import logistic. Now why logistic? Because see, the problem statement is to find out, basis on the transactional data whatever we have, basis on the transaction pattern, we need to figure out whether each of the transactions are fraudulent or the genuine one. Okay, so that's what we have to find out, and that's going to be a classification problem. Means in the result we are expecting the value as 0 or 1, right? So that's where I have decided to go with logistic regression in this video. Further we will see that, right? And then at the end, to evaluate our model, right, we would require a confusion matrix as well. I will explain that what confusion matrix is. Matrix, import confusion matrix. Oops, confusion matrix. Just 1 second. All right, so if it is taking time, so what I'll do is, let me just, here I have the spelling error, matrix. Now let's see if this works. Yeah, confusion matrix. So we are done with importing all the libraries. Now the time comes where we need to import the data. So to import the data, we're gonna say pd.read csv. That's a csv file which I have already downloaded, right? So I will directly import it from there. And where I have placed that, that's in my system. And where is the location in my system? This is the folder where I have that particular data available, and the dataset name is this. The dataset is quite huge, so it will take time whenever we perform some sort of processing. Okay, and here I will show you just 5 observations of it. So it will take time to import the data. Till the time I'll pause the video. Alright, like you can see, the data is imported. So once we have our data imported, we will just validate the shape of the data, which is nothing but checking out how many rows and columns are there. So like you can see, I said it has somewhere 6.3 million records and 11 columns. Now let me just give you a brief about the data. So this is the step variable, which is nothing but it indicates the time consumption between 2 consecutive transactions, right? Then we have the type, what sort of payment type are what sort of payment were done, whether it was transfer, cash out, or etc. Then we have the transaction amount, name of origination, from which ID the payment was originated. Then when it originated, what was the balance amount available in that particular account. Then after making this transfer, what was the balance which was available. Then the destination account where the amount was transferred. Then this is old balance data, old balance destination, new balance destination, right? This is the variable which we are going to predict is fraud, whether this particular transaction is a fraud or not. So in the data it says that this particular transaction was fraud and this was no fraud. Okay, now if you see over here, this is flag fraud. So there is a condition in the data wherever the transaction amount was, let me show it to you, is flag fraud. I'll just show it to you here. So here it says wherever the transaction amount was greater than equals to 200,000, then that was flagged as the is flag fraud. This is on their certain logic. Okay, without getting much into the data, we will just start with, I don't want to make it boring, so that's why I'll just start it. So first thing, what happens is when we are going to work with logistic regression or similar models, right? So character variables will generally not work, right? So we need to first drop the character variables. Okay, so let's start with dropping. So I will say df, and then I will put the variables which we want to drop, right? So not this way, I will say drop, and in that I will supply the list of variables which we want to drop. So this is the id variable which has no much use. Then again I have this particular variable which will again would not have much use. Then this one, sorry, after putting name original, I just need to put this one. This is the categorical variable. Okay, now we are done with removing this. What else? This variable is also not going to play much role over here because I have understood the data, so that's why I'm just directly going to drop it. I will explain you further why it is so, right? Now I will just drop this. These all are columns, so I will say x is equals to 1. Okay, now I will store this in df3. I will not make any change in the original data, right? So this data set is created. Let's have a look on this. Now this is how the data set looks. Now you must be thinking, I said to drop the character variables, but still I am keeping this type column, right? Why is that so? Because this is going to be important. These variables were mostly ID variables, right? This is not. This is defining a category of your data. So how we going to treat this particular variable? To treat that particular variable, we will first figure out how many unique values does this have. So for that, what we're going to do is df and then put the column name in which we want to check, and then use the unique function. All right, and then let's hit. Right, so like you can see over here, we have 5 unique values over here, right? So how are we going to treat this? So to treat this, like this model will understand the values in terms of numbers. Okay, so we need to provide the number. How can we put the number? We can say 1 to payment, 2 transfer, 3 cash out, 4 debit, or 5 cash in, anything, right? That way we can do the numbering. Let's understand this this thing. How does this thing work, right? And what could be the advantage or disadvantage of this? So let's say these are the 2 variables I'm taking for sample, and these are the sample data out of that whole data set. Okay, now let me just expand this little bit, and I can do the coding something like this. Wherever you see cash in, I'm saying 1. Wherever you say cash out, 2 debit, 3 payment, 4 and transfer, 5. This is how I'm giving the number. But you know what, this is not the correct way, because see, these are the numbers. If we supply the data like this, instead of treating this as a category, the model will take it as some values, numerical values, which should not happen, which is not the purpose of this model development, right? So we need to avoid that situation as well. So what is it that we can do? Let's have a look on the data again. Out of this, we will take amount separately, and what we're gonna do is, whatever unique types we have, payment types, we're gonna just take one unique item out of this and put it over here. Same for cash out, debit, payment, transfer, etc. Right? Once this is done, then we're gonna look at the amount column. Okay, this is the amount. This amount belongs to cash in, like you can see over here. This belongs to cash in. So wherever we get intersection of this column and the relevant amount, we're gonna put 1 over there. Similarly, this has the intersection here, so we will put 1 over here. Similarly for this, right, we're gonna put 1 over here. Same for this 1 over here. You don't have to confuse, right? You don't have to be confused. This is very simple. So when I put, let's start with cash in. So I will put the values like this. Let me erase this first, right? This is not looking good, right? So wherever we see the intersection of this amount which belongs to cash in, we're gonna say 1. Same for cash out, same for debit, payment and transfer, right? I hope this is clear. Now once we are done with this, what about the remaining values, right? For this area, for this area, this area and all. So for all those where it doesn't have the intersection, what we're gonna do is we're gonna put zeros. So for example, if you see over here, we had the intersection for these values with cash in, so we put 1. For this value, we don't have this intersection, we have 0. Similarly for all this, and you see vertically also, this amount doesn't belong to cash in, it does belong to cash out. So over here we have 1, here we have 0, and in the rest of the things we have 0. So I hope that it is clear to you. So what message does it pass is that simple cash in, whatever the amount belongs to cash in, that will be 1, rest of will be 0. So this will be treated as category in the model development, right? Now we are done with putting all these unique payment methods, right? But you know what happens if you are keeping all the columns, that again going to be treated differently. So what we need to do is we need to delete one of this column. You can delete any one of your choice. So here what I'm going to do is I will be deleting cash in. Now once that is deleted, you look at these three rows, top three rows. So all these three rows have zero value. What does that mean? This amount doesn't belong to any one of these four payment method. That means it belongs to the payment method which we have deleted, right, which was cash in, and that's how it will be treated. So I just hope that it is clear, right? Now you must be getting what is this called. This method is known as one hot encoding. All right, and we can use this using the pandas method get dummies. Let me just show it to you how you can do that. So over here what I will do is I'll just take the variable df dot type. Actually it should be df3, and what I'll do is I'll just put it in the bracket and like this. Okay, so once this is the variable selection. Now let me put it. Now I have to use a function on this which is pd dot get dummies. All right, so I got pd dot get dummies. So and now I will store this in a variable, let's say dummies. Okay, and let me just print this. All right, now here we are done. You see we have all these four methods. Okay, like you can see cash in, cash out, debit, payment, transfer. Let me drop cash in out of it. Okay, let me try if I can drop over here. I'll just try this. Not sure if that will work. I'm just going to try it. So that's why I said that it's absolute beginner level. It will give an error because I missed to put the axis over here. Axis equals to 1. Let's see if this works. Yeah, it just worked. I dropped the cash in, right? So after converting that, whatever came out, I just dropped the cash in variable out of that. Right, now once this is done, what we're gonna do is I will just concatenate this with our main data frame, which is df3. Let me do that quickly, and I'll create another data frame which is called df4, and in that I would say pd dot concat, and in that I will supply the list of data frames which is df3 and dummies. All right, and I have to concatenate this along the columns. So I will say axis equals to 1, and let's see how does this data frame 4 looks like. All right, now we have this converted over here. Very well, it looks good. Now because we are done with this conversion, we are very good in shape to go forward and start with the model development. Okay, you see this all are looking good. Now after this we will see if some more variable which needs to be dropped or included, we will do that as well. Okay, so let's start with that. So first thing which we require to do is split the data in train and test form. Right, first we also need to decide dependent and independent. All the variables are independent except this is fraud, right? So we will put it separate and rest of the variables together. So how we gonna do that? So for that we will say df4 dot drop, oops, just bear with me, df4 dot drop. Inside that, out of that I am going to drop is fraud. This will be our training data. Okay, and I need to drop it along the axis. So what I'll do is I'll just say axis equals to 1. So this is the set of our independent variables. Now what about the dependent variable? That is df.4, and I'm going to say is fraud, right? So this is done. Now now we have to use the train test split function on this, and we need to store these values in the variables, and those variable we can get from here. This is the description of train test split, which you can go through and just check it out. I also do that, right, whenever it is needed. I also try that. This is the best way. So from here what I'll do is I'll just pick all these variables out of it, okay, And once this is done, what I will do is I'll just put it over here. Okay, now let's just give some time. It will take some time to do the kind of a split. Yeah, it is done. Right, now let me just give you a view of the data. Let's just have a view of this data. Oops, I forgot to put the test size over here. Test size will be, I will take 20% as test size, and random state I'm going to take as false because I want to keep on using the same data set. Okay, all right, so this is also done. Now let me show it to you. Let me show you the shape first of training data. So in training data we have these many rows and number of columns are these, right? Okay, before that I will just give you the view of df4 shape. What is the, because you know we added many columns also, so we have in total 12 columns in the data and these many records. Now after this xtrain, let's see how does xtrain looks like. So oops, here I should say head, and here we have these many records. Okay, so sorry, this is how the data training data looks like. So this is 80% of the data. Now if you want to see the y variable, you see this is how the dependent variable looks like. Okay, now if you want to see the x test, what is the shape of that, you can just check this out. You see this is 20% of the data. All right, now we are done with checking out the data. I believe you are confident with this. Next thing which we're gonna do is we're gonna create model equals to, I would say, logistic regression. I'll just create an object. So the object is created. Now I'm going to say model dot fit. It's very similar to what I have covered in the previous video. Link is available in the description section, you can check that out. Okay, model dot fit, and inside that what I'm going to do is I'll just put x train comma y train. All right, this is done. Now once this will be done, this is still progressing, like you can see the star over here. Oops, there seem to be some issue. Let me figure it out what the problem is. Could not convert a string to float, cache out. Okay, there seem to be some problem. The data set which I used is df4. I'll just check it out. All right, so what we did is here we concatenated the data frames, but we didn't drop the type column. So that is very much important, right? Why that is, this is the reason it was giving the error. So again I'll try this over here, and in this I'm just going to say type, and over here I would say axis equals to 1. Let's see. Oops, oh, it just worked. Right, now the type column is gone, and after this I can do this. Let's see what comes out of it. Okay, let's just wait. All right, now we are done with fitting the model. Let's check out the score of this. What is the score that we are getting of this model? So for that what we're gonna do is we're gonna use x test comma y test, and let's see the score. Oops, this is 99%. It says 99% the prediction is correct. Is it possible? This is very good, right? But no, don't worry, this is not good. This can be treated as overfitting. This is happening because of the imbalanced data, right? Unbalanced data. Let me show you how. So if you check df4 dot df4, let me pick the column which is fraud. All right, and then let me just give you the unique of it. So if you take unique of it, you see, all right, just let me try. Okay, this is the unique values. So you can see there the unique values are 0 and 1. What next we can do is we can use group by, df4 dot group by, and inside that we can put the same variable which is fraud, and then Let's see, and then let's try if sum works over here, and let's see the count for each of these two categories, right? So you can ignore rest of these variables, or if you want you can just pick any variable over here. Step, oops, there seem to be some problem, just bear with me. Or for now let's do one thing, let's not complicate this and keep it simple. What we can do is you can just focus on this part. So if you see, these many are fraud and these many are non-fraud, so the proportion is too, you know, it's drastically imbalanced. It's kind of imbalanced data, right? So the proportion is too low. Possibility of fraud is too low based on this data. That is why it is giving us the 99%. To make it more clear, I will show you a confusion matrix, but before that let me explain you what confusion matrix is. So to explain that, I will take you over here. So confusion matrix is nothing but it's a 2 by 2 table, right, where at y-axis we put the actuals and on x-axis we're gonna put predicted values. So in our case the values which we have is fraud and no fraud. Same for predicted also. We are trying to predict and then we will see. Now if you focus on this particular box, so here what we predicted is fraud and what actually it is also fraud. So it's the intersection of this and this. So this area will be termed as true positive. Why? Because what we predicted is positive and what actually was, that was also positive. That's why it is true. Our prediction is true. It says our prediction is true. Now next one, let's look at this particular box. Okay, so over here what we are predicting and what actually it is, basis on that we come up with this conclusion. Because what we predicted is negative, we said that this particular record is negative, which is actually true because actually the data also says that it is negative. Now on the flip side, let's have a look on this particular segment. Okay, here our prediction is fraud. That means we are saying that it is positive, right? Positive means it is fraud, right? So our prediction is positive, but in reality that is not fraud. That means our prediction which is positive is false, and hence this kind of prediction is referred to be as false positive. Same over here. Here you see our prediction is negative, which is actually non-negative. That means our prediction is false and hence we call it false negative. So this is our confusion matrix. We usually use this to predict, you know, to measure the performance of our model in more comprehensive way. Now let me take you to the Jupyter notebook and show it to you. Okay, so how can we do that? You remember in the beginning we imported one module which is called confusion matrix. Okay, so same thing we're gonna use over here. We will use this confusion matrix. Before that, what we need to do is we need to do the prediction. So model dot predict, okay, and in that the value which we're gonna provide is x test data set, and we will just store this in a variable. Let's call it predict, and if you want you can just print that also. And here is the prediction. Okay, it's gonna be long list, right? So let's just forget that to print further. Why I did this? Because I would require that in the confusion matrix. Okay, and over here what I'm going to do is predicted. All right, and before that what we can put is y test, and let's see. All right, here we got the output, right? So you see these are the, here we have actuals and here we have predicted. Now we will try to visualize this with the help of heat map. So for that what I'll do is I'll store it in a variable called cm, and here I'll just create a heat map plot, sns.heat map, and inside that what I'll do is I'll just supply the data cm, and let's see how does this looks like. So this is how it is looking like. It's not looking much better. So what I'll do is I'll just use different color map, C map, which is called C map, and here I would use, you know, red. Let's see. So if there is some color palette, no red, there isn't anything called red, so we will have, you can pick any one of this whatever we have. That's why I intentionally put over there, because it will give the error and you would understand what to use, right? So from here you can choose any one. I'm just going to use orange. Here I'll use orange. Oops. It doesn't seem to be in favor. Alright, so instead of orange we have to call it oranges, right? So just come over here and put oranges. Now let's see how does this looks. This is still better, isn't it? Now I will also put the numbers over here, right? The numbers are to put that, we can say annote equals to true. So when you do this, this is what you get. Now this is not looking good, the numbers are non-readable. So what I will do is, there is one parameter which is called fmt, and I will make it digit. Now if you see, you can read it pretty well, right? The numbers are readable pretty well. Now to look it much better, I will drop this particular column from here. So I will say c bar equals to false. Now if you see over here, the column is dropped. To make it more better, what I'll do is, I will just use line color as black. Let's see if we have this. Line width, we're gonna use little bit of line width, which let's say 5. Let's see how does it look. Okay, still better, right? Now if you see over here, see 900 in total, these many frauds were there. Okay, in total this many. If 0 and 1 is something which is creating the confusion, so to fix that, what I have done is, I have a palette created previously over here. To save the time, I'm just taking it from here and put it here, just in case if you want to understand, just let me know, I'll explain them all. So now if you put it over here, and if you have a look over here, these many were fraud, and out of this, if you see, more than 50% of the more than 50 approximately whatever fraud were there, somewhere 50% of the even less than 50% rather, I would say, right? It is it is false, sorry, true positive, right? But rest of them, if you see, it is false negative, right? So this is, you see, this is not correct. Here we are predicting to be no fraud, but that is actually fraud. And why we are getting 99%? Because of this area. These many accounts, these many transactions are not fraud, and our model is also predicting it to be no fraud, right? So that's why we are getting 99%, because this is the largest volume in our data, and that, which is why it is causing the 99% of accuracy. But if you see, this is drastic, right? If you sum this up, 965 and 676, it will be somewhere 1600, right? 1600 out of 1600, 965 are wrongly predicted, right? Which is quite huge, right? The difference is quite huge. So we cannot say that this prediction is right. Okay, whatever model we have built, that is not 100% right. So in the next video we will see what could be the better solution, right? I'll come up with the next part of this video. Until then, I just believe that it give you an idea how to approach a model building thing, right? I just hope that you liked it. Please be patient and stay with me. In the next video, we will come up with an alternative of this. This is how we develop. We try one model. If that doesn't work, then we try the another model. So that's why I'm taking it this way. Otherwise, I could have found the best fit model and then I could have shown that. But I wanted you to give, I wanted you to get the feeling of actual work. That's why I did it this way. Please be with me. In the next video, I will definitely come up with a better alternate. Thank you very much for watching the video. Wish you very good luck.